Hey everyone, I hope you're doing well. Let's start today off by logging into Clever. All right, so for your warm up, I'd like you to describe something you are looking forward to today, tomorrow, next week, next month, next year, whatever. But what is something that is going to bring you joy and that you are looking forward to? Thanks for sharing. So, welcome to lesson 10. We are on week 6. Holy cow. And this week we're focusing on water treatment and what that looks like. So, my regular announcements for you, make sure you're checking assignments from previous weeks for comments, and especially as they get returned, the grades. Realize that anything that gets returned, you can turn back in for an improved grade. And I will take it without any questions. Okay. With the Ed puzzles, I have had in the past week in particular a bunch of people turning Ed puzzles in with either not having done them or not having finished them all the way. So if you turn it in and there's not a grade that pops up automatically, that means that you either didn't do it or you didn't finish it. So make sure that you're being really, really focused and intentional about making sure that your Ed puzzles are completed all the way through. I hope that you guys are trying to come to these live lessons. But if you're not, thank you for watching the Ed puzzle that you're on right now, because you're still going to get the same kind of content and work in. Remember, we're going to continue to practice these expectations if you're in my live lesson, if you're just doing your virtual work, or when we get to be back together in class. So, this week, like I said, we're talking about how water gets treated to be safe for us to consume and use. So, we spent a decent amount of time thinking about where do contaminants come from, what are contaminants that come from that source or from those sources, and now we're going to think about how we get those things out of our water. So we have a full week of assignments. Hopefully, you've already done the week 6 preview. There are a set of Cornell notes as well as a text assignment that are going with this lesson. And then later in the week, there's 2 assignments that will hone in and have us focus on Louisville, particularly, and their water treatment process, and finishing with a check for understanding quiz. As always, I hope that you've not done the assignments 22 or 23 yet. You should always do this lesson first before you attack those, okay? And some other things to just keep in mind. It is the end of a unit, and that is coinciding with the end of the first 6 weeks. So I think the end of the first 6 weeks is either the end of this week or sometime early next week. And this week is our last week of new material for this water unit. So next week we'll be doing kind of a catch up and review day, as well as then our assessment over this unit. So it's super important for multiple reasons to be getting caught up. One is because you're taking this assessment soon, you want to have all of that information, have all of that work done so you're ready for it. But also you want to have it all done because it's the end of the 6 weeks and I have to post grades. Okay. So keep working to get caught up. You can do the work whenever works for you. Don't feel any shame or anything like that. Do the work whenever it works for you, but just do it. Okay. Do something. Thank you guys, as always, for putting in that effort and for showing up and being here and taking part in this. I know it's not easy, but we're going to continue pushing and growing and learning. So let's remember from last week where we talked about the sources or the general places where water contamination can happen. So, what do you remember are the major sources of contamination, the major places where water contamination can occur? So, if you remember, we have 5 major categories. Agricultural is talking about farming. So, any sort of either a produce or animal farm, livestock. Commercial is related to businesses, so restaurants or different businesses where goods or services are sold. So, like a laundromat or a nail salon or a car shop, right? Those are commercial sources of contamination. Industrial is related to factories where they're creating or building things. And then residential is those are contaminants that come from where you live, your home or your apartment or somewhere like that. Everything else can kind of fit into the other category. So then, as we think about those sources, so think about the kinds of contaminants that might end up in our water from these different places. Let's brainstorm what are some common contaminants that can be found in our water. So, some common contaminants coming from all of those places are as follows. So, no matter what, no matter where, and it isn't even from one of those sources. If your water is coming from any sort of stream or waterbed, they are going to have rocks and sedimentation and dissolved minerals in them. In small amounts, those are okay, but in large, like in larger amounts, they can cause some negative health effects. And so, if you've ever heard hard water, that is what we're talking about when things like magnesium and calcium and sodium are dissolved into your water from the natural rocks that are found wherever your water source is. Well water into and specifically has problems with hard water. Um, from agricultural settings, you'll see a lot of nitrates and phosphates because those are the chemicals that are found in fertilizers and pesticides. Bacteria that can come from any of the bacteria and viruses and other pathogens like that, that can come from any of the sources. But particularly sewage, you would think is coming from residential settings. So bacteria like E. coli and other and other parasites can make you like very, very sick. So if you've ever had a stomach bug, it can be attested to E. coli. And then other contaminants that can generally or commonly be found in your water come from more of industrial or urban settings. So some of these metals or like lead and arsenic, and iron, those can be found not only in industrial settings, but also just from the pipes that are used in your home. Things like radon and chromium 6, those are specific contaminants that would maybe end up in your water from factories where they're creating or making something. Those might be byproducts that can end up in your water. So it's kind of scary to think about all of this stuff that might be in our water without us knowing it. But the reality is that we thankfully have put our trust into water treatment companies that are able to um, get our water clean and safe for us to use. Okay, so let's start and think. How would you remove something like this, dirt and mud, from our water? What would you maybe do? Okay. Now, what would you maybe do to remove dissolved substances in our water? Great. What would you do to get bacteria and harmful pathogens out of your water? All right. And what about like large debris like you might see here? How can we get that out of our water? Great. So there are two major categories of ways that we are able to separate or remove things from our water. Physical is where it's not involving chemicals, it's just kind of using physical ways to separate. And then chemical ways, chemical means are going to be by taking advantage of chemical reactions that cause things to happen. So, first of all, sedimentation, that's one that most people don't think about, but it is a pretty obvious one. Or settling is when you kind of just give water time to sit without moving, and that causes dissolved substances, particularly like dirt and mud and silt, to settle and sit down at the bottom, allowing you to remove that from the water. Filtration, that's one that a lot of folks talked about. Filtration is using some sort of barrier. And filters can be multiple things, but using some sort of barrier that allows some things to pass through, but not large things, particularly. That's what we're thinking about with water. So the water is able to pass through, but larger dissolved things get caught in it. So they can be filters can be made from many things. This is actually a common one that is used in water treatment facilities. If we were together in person, we would do a really cool lab where I'd actually let you guys build your own filters, and we'd see whose filter setup is the best. But filters are a great way to remove large debris, because if you just set up like some sort of like screen or a net, it will allow the water to pass through and pull out the garbage and extra crap here. Or with this example, this water here, a more fine filter might collect some of the dissolved pieces of mud and silt and dirt that are in there. So like a coffee filter or some sort of mesh like that. Next is distillation. And so this is like boiling. So when you boil water, you can collect that water vapor, and reconstitute it back as liquid water. And then what's left behind is whatever was dissolved in it. And so that's commonly used. It's also, boiling water is a good way to kill any bacteria, because bacteria can't live in that high of a temperature. Now, our chemical means, coagulation is a weird, scary word, but what it is saying is you add a chemical that kind of forces mud and dirt particles to stick together. And then, if you give those time, they will settle to the bottom with that sedimentation, and you can remove them in that way. So, that's a really nice way. If you add that here, this will clean this up even more. It'll force, excuse me, those kind of suspended mud particles that are in the water here to clump together and then sink to the bottom with the rest of those, that mud and dirt and silt. The last chemical means to help remove things from water is disinfection. And many of you guys did talk about that. With disinfection, that's killing and removing any bacteria that could be harmful. So, boiling is a great way to do that. However, that takes a lot of heat and energy. And so, if we're talking about large scale water treatment, that's not really feasible. So, what is actually added to your water are chemicals that will kill the bacteria, the most common one being some form of chlorine. All right. So this whole process to treat your water actually pretty much undergoes all of those different means that we just discussed. So removing large debris happens right at the beginning. Then they use a coagulation to collect dirt and clumps, so that then it settles and sedimentation occurs and sets at the bottom. So again, it's talking about sediment drops to the bottom. Then they disinfect it either once or twice. See, there's that disinfectant using chlorine. Then there's some sort of filtration to remove any last other particles, and then it ends up in your water. And this really is kind of the basic process. There might be some tweaks in the order that things are happening, or what specifically is being used based on the chemistry of the water source. But that's the basic process. So, what you're going to be doing is spending a little bit more time and specifically taking some notes about this process. Number 22, you're going to be doing another set of Cornell notes. You can either write it on your own, or you can use the doc that I have provided. You're going to get your notes from the Google Slides that are posted right next to it. And as always, available to you, if you prefer to have me kind of like walk you through it, this Edpuzzle is a recorded video of me stopping exactly where you need to be, what you need, and telling you what you need to write down, as well as just giving you some personal anecdotes if that helps you remember things better. If you're a learner that needs to hear things rather than just see things, this might be a good option for you, but it is not required. So your basic water treatment notes are going to look something like this. We're thinking about, how the heck do we clean our water? Again, you can write this on your own piece of paper, or you can do it on that document. I do not care. And we're going to continue to follow this Cornell note structure. So the two columns on your paper, the left column is going to be for the title of the slide. The right column is where you're going to put your notes, your definitions, your pictures, whatever information that you need to gather from the slides. But this time, I am not providing you with the specific slides. In the previous time we've done Cornell Notes is where I'd have the slide, and then I'd have the Cornell Notes version of what you're going to write down. We've done that enough now where you should be able to pull the information that you need from the basic slides, okay? Again, if you need, the Edpuzzle is a way where I am even more intentional about making sure you know what to write down where. So, for example, the first slide that you're going to have to write down in your notes is about defining what turbidity is. So, turbidity is how cloudy a sample is, this being the most turbid, this being the least turbid. The more turbid your sample is, the dirtier it looks. It's probably not safe for you to consume or use. So, good water, we're looking for clean, low turbidity, and not seeing anything dissolved or cloudy in it. Okay, so what you would write down in your notes, I'm not doing this for every single notes or even in any of the notes. I just wanted here to make sure we all understand. You write down the title in the left column, right? And then you write down these notes and include any pictures if you want. You can copy and paste them over in the right column. So how cloudy it is, a sample is what turbidity is. More turbid a sample is equals less likely it is safe to consume. All right. And so you'll do that for the remaining number of slides in that assignment. So that's the Cornell Notes assignment here. The other assignment is a from River to Text, River to Faucet text, where you're going to be opening a text from the Louisville Water Company and answering some questions based on the text. Each question in the Google form at the beginning, it'll tell you specifically where to look in the text to find the answer to kind of help you out and make it a little bit easier of a transition between the two. All right. So, how interesting and challenging was today's lesson for you? Good. I hope that it was just right. But that's all I have for you today. If you don't have any questions, please go ahead and finish things out. If you do, don't be afraid or hesitate to ask me here or to ask me in an upcoming assignment or email. All right, you all, I'll see you next time. Have a great day.